Okay. So now we'll go ahead and finish up chapter 10, section 10.4. And that's going to cover measures of central tendency and variation. This will not be on your second exam. Okay. By the way, the second exam covers like 9.1, 9.2, 9.3, 10.2, and 10.3, and that's just about it. But this will not be on your exam number 2. But I'm going to go over it anyway. It'll be on the next exam. So section 10-4, it deals with measures of central tendency and variation. So what we'll look at is how to calculate things like the mean, median, and mode for a set of data. And then we'll calculate measures of variation for a data set. What that means is finding the range, the variance, and the standard deviation of a data set. Also, we're going to use something called box plots, and that is to analyze and compare data sets. And I'll show you how to construct a box plot. Then we'll look at applications that involve the normal distribution, also percentiles, quartiles, and deciles. Okay. All right, so we'll start off with measures of central tendency. Okay, now, when we're dealing with measures of central tendency, we're going to be dealing with things like the median, the mean, the median, and the mode. Now, in statistics, there are 2 important aspects of data. That is the center, where the data is centered at, and how the data is spread or dispersed. Okay, so our measures of central tendency usually going to be the mean and the median. And also we'll look at the mode as well. Okay, those describe where the data are centered. Whereas for the range, also they have interquartile, variance, mean absolute deviation, and standard deviation. They describe the spread of the data and should be used with measures of central tendency. Okay, because in order for you to find, let's say, the standard deviation, you have to know what the mean of that data set is. Same holds true for variance. And also to, what else? Find that interquartile range. There's something else you need to know. You need to know how to find the median of a data set. So that way you'll be able to find the interquartile range. Okay. All right, so here we're gonna start by computing the mean. And we use the phrase arithmetic mean, which is also called the average or the mean of a data set. And to find the arithmetic mean of numbers from x1 all the way to x of n, we denote the arithmetic mean by using this notation x bar. And that's going to be given by this. X bar is going to be equal to x1 plus x2 plus x3 all the way to plus x of n, all divided by n. In other words, all you're going to do there is just simply add the data values that you have in that set and divide that by the number of data values in that data set. Okay, that's just how we find the arithmetic mean. Okay, and in a few minutes, we'll look at some examples of just that. All right, so for understanding the mean as a balance point, okay, so if we had, let's say, this dot plot, which has x's here, if we were to take the sum of these 6 numbers and divide by 6, you would get the mean of 5. And what that mean represents in this case is just going to be the balance point where the sum of the distances from the mean to the data points above the mean equals the sum of the distances from the mean, excuse me, to the data points below the mean. Okay. So here we have points that are below the mean, like 4 data values are below the mean, and also the 2 data values in this case that are above the mean. Okay. So here, the mean is usually considered to be the balance point. Okay. So in this case, to simplify that, here the sum of the distances above the mean is going to be 3 plus 5 or 8. So here, this 8 is 3 places to the right of the mean, and the number 10 is 5 places to the right of the mean. So if you add 3 and 5 together, you get 8. Whereas here, the number 2 is 3 places to the left of the mean. The number 3 is 2 places to the left, and the number 4 is 1 place to the left. So if we add 1 plus 2, and then plus 2 plus 3, you'll get 8. Okay, and the reason for that here, 3 is the number that's used twice. Okay, so the data are centered about the mean, but the mean does not belong to the data set. Okay. Because if you look at, well, pretty much if you look at that dot plot, you're going to see that 5 is not one of those data values here. Okay. And it is possible to rearrange the data to have the same mean, but the spread can be very different. So like here on the left side, you see these numbers 2, 3, 3, 4, 8, and 10. Which are those data values that was from that dot plot that I just showed you. So if we add these numbers together and divide by 6, and of course that sum is going to be 30. 30 divided by 6 will be 5. Well, let's say we have something like this: -3, -2, -2, -1, 18, and 20. In this case here, we can add these numbers together. You're going to see that it will end up being 30, and 30 divided by 6 will give you 5. So here the mean is still going to be 5. So here we can rearrange the data and have that same mean, but the spread could be different. Questions about finding the mean. And we'll look at some examples here shortly. All right, next we'll look at the median of a data set. The median is always going to be the middle number of an ordered set of numbers. Okay, that's going to be very important because that phrase ordered set of numbers means that we must put our data set in numerical order from least to greatest, or from greatest to least, but preferably least to greatest. Okay, so to find the median of a set of numbers, we arrange the numbers from least to greatest. Now, if you have an odd number of data values, like let's say you had 5 or 7 or 9 or 11 data values, then the median will automatically be the middle number. Or if you have an even number of data values, like if you have 6 data values or 10, or let's say 16 data values, then that means we have to take the mean or the average of the 2 middle numbers. You want to make sure your data values are in numerical order, and then find the 2 middle numbers and take the average of the 2. And that will tell you what the mean is. But that's only for an even number of data values. For an odd number of data values, you take the middle number directly. Okay. Now, the median is often going to be reported with something called the interquartile range. Now, later on in this section, we're going to talk about what an interquartile range is, and also how to compute the interquartile range. That's just a measure of spread that shows where the middle half or the middle 50% of the scores lie within the median in that range. Okay, and the two together form a much better pair and describe the data than just the median itself. Okay, now later on, we're going to talk about what interquartile range is, how to compute the interquartile range. It's simple. All right, next is finding the mode. And that's sometimes reported as a measure of central tendency, but when it's reported in that form is often misused. Okay, because by definition, the mode is going to be the number that appears most frequently. If there is one, but the mode does not have to be in any way a measure of central tendency. Usually we report a mode with categorical data. So if I go back to this dot plot, pretty much I can go back to this right here, this table. The mode in this case would be 3, because that number occurs more often than the other numbers in that data set. Now, a mode, you could have more than one mode or none at all. So let's say in this case here, let's say we had a data set like 4, 8, 13, then 13, 19, 22, 22, and 30. Okay. This is just a data set. And if I want to identify the mode, there are 2 of them. One is 13 and 22. Because 13 appears twice in that data set, and so does 22. It appears twice in that data set. So it is possible to have more than one mode. And in this case, since we have 2 modes, we consider that to be bimodal. And let's say we had another data set like in this case here, each number occurs only once. So this is an example of a data set that has no mode. Because each data value occurs only once. Okay. All right, any questions on this? All right, on the next page is the first example. Does everyone have this? I'll just erase this. All right, so in this case here, in the first example, it says here, calculate the mean, the median, and the mode for each of the following data sets. So in part A, we got 2, 7, 7, 8, 6, 7, 11, and 3. And here I want to find the mean, the median, and the mode of this data set. Well, before I do anything, what I need to do is put this data set in numerical order from least to greatest. So what I need to do here is put this in numerical order. So I'm start with the 2, and then 3 will be next. 4, 5, plus 6. And then I got 7 3 times, and then 8 and 11. Okay. And I do have all the data values here. So this data set is in numerical order from least to greatest. And now I can go ahead and find the mean, the median, and the mode of this data set. All right, to find the mean, all we do there is take the sum of those data values and divide by how many data values that I have in this set. So this is just going to be 2 plus 3 plus 6 plus 7 plus 7 plus 7 plus 8 plus 11. Divide that by how many data values do I have here? 8. So in this case here, 2 plus 3 plus 6 plus 7 plus 7 plus 7 plus 8 plus 11 is how much? How much? Oh, it's 51. That's what I thought, because that's what I came up with. Now 51 divided by 8. Okay. So the mean of that data set would be 6.375. All right, now for the mode. Okay. Okay, yeah, it's 7, because 7 occurs 3 times. That's the data value that occurs the greatest. Okay. And I skipped over the median, so let me go ahead and find out what that median is. Now, the way you can identify the median of a data set would be this. What I would do here is cross out the data values. If it's in numerical order, you can cross out the data values on the left and the right side, and keep doing that until you get to your middle number or the 2 middle numbers. And in this case, it's 7 and 7. So the median, that's 7 plus 7, we divide that by 2. So we take the average of the 2 middle numbers when we find the median in this case. So this will be 14 over 2, which is 7. So the median is 7. And the reason why I had to take the average of the 2 middle numbers because I have an even number of data values here. Okay. All right, any questions about part A? All right, let's see here. Let me do part B, because this one has an odd number of data values. I probably kind of gave that away. Okay, we got 10.5, 12.5, again 12.5, 14.5, 20.5, 16.5, 12.5, 15.5, and 11.5. Well, first of all, we need to put these data values in numerical order. So in this case here, let's see, the smallest is 10.5, I believe. And then we got 11.5. And I see 12.5 3 times. A couple of 14.5s. Let's see, 16.5. And 20.5. So I should still have 9 data values here. Yeah. All right, so let's first find the mean. And I'm not gonna, write the whole thing out on the board. So it'd be 10.5 plus 11.5 plus 12.5 plus another 12.5 plus another 12.5 plus 14.5 plus 14.5 plus 16.5 plus 20.5. So I now have 125.5 That's going to be divided by 9 because there are 9 data values in that set. And let's say to 1 decimal place, what would your mean be? Okay. So the mean would be approximately 13.9. And here I got 13.9 with a 4 repeating. So the 1 decimal place would be 13.9. Right, next, we'll find the median. And of course, what would that middle number be? 12.5. And the way you can get that is cross the data values out on the left and on the right and keep doing that until you get to the middle number, which is in this case 12.5. All right, now for the mode. What number occurs the most frequent? Just the one that occurs more than any of the other numbers. Just the 12.5, even though 14.5 occurs twice, but it's the 12.5 that occurs the most often. So the mode is 12.5. Okay, questions on part B? Okay. All right, let's look at part C. This one has a few negative numbers here. So let me erase this part A. And we'll do part C up here. And in this case here, we got 5, negative 4.2, negative 5.4, 6.2, 0, 3.2, 10.3, and 0.9. So now we need to place these data values in numerical order from least to greatest. Well, let's start with the negative numbers here. The one that's furthest to the left of 0 will have to be negative 5.4. So that goes first. And then negative 4.2. And then we got 0. And then next is 0.9. 2.2 is next. And then 5. And then 6.2. And 10.3. Okay. Just want to make sure I have all my data values there. So that's the sorted data set. And now let's find the mean of this. So now we have negative 5.4 plus negative 4.2 plus 0 plus 0.9 plus 3.2 plus 5 plus 6.2 plus 10.3. I got 16, and 16 is going to be divided by 8, which is, of course, 2. So the mean of this data set would be 2. Now for the median. That's going to be the middle number of this data set. I cross the numbers on the ends. Here I got two middle numbers, 0.9 and 3.2. So I need to take the average of those two, 0.9 plus 3.2. Divide that by 2. Because that's 4.1 divided by 2, which is 2.05. So the median of this data set would be 2.05. And then finally, we need to find the mode. What would be the mode of this data set? Is none. Each data value occurs only once. So there is no mode for this data set. Any questions on part C? And part D. '73, '78, '86, '78, '72, '75, and 5. And first of all, we need to put these in numerical order. So we start with the 5, and then 72, 73, 78, and then another 78. See something at 5, 72, 73, oh, 75. And then 78. And then finally 86. Now we're ready to find the mean. So you have 5 plus 72 plus 73 plus 75 plus 78 plus another 78 plus 86. That sum is 467. That's going to be divided by 7. Okay. So one decimal place, that'll be approximately 66.7. Okay. Now for the median. Okay. To find the median, we have to find the middle number. Pretty much that middle number will have to be, has to be 75. What would be the mode for this data set? 78. So the mode there will be 78. Okay. All right, any questions about example number 1? Okay, so that's the first one. All right, let's look at the second one right here. Here we're going to complete parts A and B. If 3 students score 80 on a test and 3 other students score 87 on the same test, find the mean, median, and mode for the test scores. And then in part B, the mean score on a set of 16 tests is 75. What is the sum of all the test scores? Okay, so three students scored 80 on a test. So I'm going to write this out as 80 written 3 times because three students scored 80 on the test. The other 3 scored 87 on that same test. So 87 twice. And then we're going to find the mean, median, and mode for the test scores. Okay, so well, the data set's already in numerical order from least to greatest, so we can go ahead and find the mean, median, and mode for that data set. So that means I have 80 plus 80 plus 80 plus 87, 87, 87. So the sum is 501 divided by 6. What did we get for a mean? 83.5. So the mean of that data set is 83.5. Now we need the median of this data set. Well, by looking at this, if I cross out the numbers on the ends, you're going to see that 80 and 87 are my 2 middle numbers. So I need to add those 2 middle numbers together and divide by 2. 80 plus 87 is 167. And what's 167 divided by 2? 83.5. So the median is 83.5. Now, what would be the mode of this data set? Nope. The mode, most frequent. They're both 80 and 87. Okay. 80 and 87. This is considered to be bimodal because we have 2 modes. Again, you can have more than one mode for a data set or none at all. Okay. Questions on part A. And then in part B, the mean score on a set of 16 tests is 75. What is the sum of the test scores? Well, if we know what the mean is, that's 75. There were 16 test scores that were that we had. Okay, so here we're going to work backwards, find the sum of those test scores. So we have to do 75 times 16. That'll be 1,200. So the sum of the 16 test scores is 1,200, and that's all they asked for. Questions on example 2. All right. Example 3 looks like this. The mean score on a set of 15 tests is 86. Suppose 2 more students take the test and score 68 and 58. What would be the new mean? What would be the new mean? Okay. So I'm going to do problem number 3 down here. 15 tests has a mean of 86. So let's first do 15 times 86 for the sum of all 15 test scores. So we do 15 times 86, you're going to get 1,290. Okay, 2 more students take the test and score 68 and 58. So that means we need to take that 1,290, add the 68 and the 58 to it. And you should get a sum of what? 1,416. And now to find that new average, we're going to take the 1,416. That's going to be divided by 17. Because 15 students already took the test, and now you got 2 more students taking the test. So that's a total of 17 students that took that test. So 1,416 divided by 17 would be, let's say, the 1 decimal place. 83.3. So the average, the new mean, which is this right here, would be approximately 83.3. Okay. Questions on problem number 3? All right, let's say in this example, Lindsay's class had 5 students who scored 90 on a test and 7 students who scored 60 on the test. What is the mean of the scores in the class? All right, so let's, let me give you a quick way of doing this one, because we don't have to write out 5 90s and 7 60s on a test. We can do this. Five students scored a 90 on the first test. So if I do 5 times 90, that's going to be how much? 450. And then you got 7 students who scored a 60 on the test. So what's 7 times 60? 420. Now let's add 450 and 420 together. Should get 870. And then how many students that took the test? 5 and 7 is what? 12. So if I do 870, let's say the mean equals 870 divided by 12. $72.5. So the mean here will be 72.5. All right, questions on example 4. Okay. Now in example 5, you're asked to find the grade point average. And we're to assume that the grade point values are 4.04 in A, 3.04 B, and so on. All right, this is just an example of what they call the weighted mean. Because the mean, the weighted mean is when they use weights like for an A having a value of 4, a B having a value of 3, a C has a value of 2, D has a value of 1, and F has a value of 0. So I'm gonna erase all of this. Okay. So A is 4 points, B is 3, C is 2, D is 1, and F, of course, is 0. Okay. Now here you have the course, and then the credits for each course, and the grade. So you get math, 5 credits, that's an A. English, 3 credits, it's a B. Physics, 3 credits, that's also a B. And German, 3 credits, and that's a C. Okay. So the way we do a weighted average for GPAs is this. We take the number of credit hours, and it's going to be multiplied by the point value for each grade. So in math, it's a 5 credit course. You got an A in that course. That value is 4 points. So I'm going to write the 4 here. So if I do 5 times 4, that's going to be 20. And the B is worth 3, so I'll put 3 here and a 3 here, and the C is worth 2 here as well. All right. But English is a 3 credit course, 3 times the point value for a B, which is 3, so 3 times 3, which is 9. Physics is a 3-hour course. The B is worth 3 points, so 3 times 3, which is 9. And then German is a 3 credit course with a grade of, he got a grade of C, which is 2 points, 3 times 2, which is 6. Now I'm going to add the 20, the 9, and the 6 together. That's going to give me how much? 34. Okay, now to find the GPA, or the grade point average, it's going to be total points divided by the total credit hours. So in this case here, the total points comes from here, that's going to be 44. Divided by the total number of credit hours that this person took. How many credit hours did this student take? 14. Okay, so this is the 14 right here. So if I do 44 divided by 14, and let's say to 2 decimal places, what would that be? What was that? 3.14. So this person has a GPA of 3.14 for that particular semester. This is an example of something that's called the weighted mean. Okay. Some textbooks call it that because you're looking at the weight for each one of those classes based on the number of credit hours to the grade, the value of that grade. Okay. Questions on example 5. All right, let's say you had something like this. All right, let's say the following table gives the annual salaries of 40 dancers in a certain troupe. And in this case here, we want to find the mean annual salary for the troop, and then find the median annual salary, and then find the mode. All right, let's see here. All right, does everyone have this so I can erase this? Okay, truth, I'm not going to write all these salaries out. All right, so for the mean, there are 40 dancers here. So the way we find the mean will have to be this. You have to take each salary, which is $18,000, for example, multiplied by the number of dancers, which is in this case 5, plus 23,000 times 2, because there are 2 dancers with that salary of 23,000, and then 27,000 times 4, then 34,000 times 7, plus 37,000 times 15, 45,000 times 1, 50,000 times 1, 80,000 times 3, and plus 150,000 times 2. Now, all that's going to be divided by 40. So if I do 18,000 times 5, then 23,000 times 2, 27,000 times 4, 34,000 times 7, plus 37,000 times 15, plus 45,000 times 1, plus 50,000 times 1, plus 80,000 times 3, plus 150,000 times 2. Okay, and for the sake of time, this is what I came up with. And that amount has to be divided by 40. Which will be $41,800. So the mean of that would be $41,800. Okay. Questions on part A? All right, now let's look at part B, where you're going to have to find the median annual salary. That would be the middle number. Now, let's think of this. The middle number, what's half of 40? Be 20. So that means we need to find the 20th number in this data set. And by looking at this, let's see here. If I add 5 and 2, that's going to be 7. Then 7 plus this 4 would be 11. 11 plus this 7 would be 18. So that means somewhere with these 15 dancers, I have the 20th number in this data set, which will have to be, in this case, 7,000. Okay. What was that again? Oh, it's already in order. It's already in order for least greatest. Yeah, you got to write them all out, and that would be time consuming. Okay. Yeah, it's still going to be 37,000. So the median is automatically going to be 37,000. And by the way, half of 40 is 20. So that means I have to look at the 20th and the 21st number. So the 20th and the 21st number, if I was to write out that data set, will be 37,081. So the median is 37,000. And what will be the mode here? 37,000, because 15 dancers have this salary of 37,000. So median is $37,000, and the mode is also $37,000 because there are 15 dancers that have that salary of $37,000. Okay, questions on number 6, where this comes from. Okay, let's look at number 7. To get a B in math, Alexandria Pappas must average 80 on 5 tests. Scores on the first 4 tests were 80, 76, 83, and 78. What is the lowest score that she can get on the last test and still get a B? Okay, so an 80 on 5 test, average of 80 on 5 tests. So in this case here, what would 80 times 5 be? 400. So that means for her to get at least a B, which is going to be 80% or 80, she has to have 400 points on 5 tests. And she already has an 80, a 76, an 83, and 78. This sum adds up to what, 317? All right. So now, 80 times 5, that's 400. So that means if I subtract the 317 from 400, what would that be? 83. So in other words, for her to at least get a B, which is an average of 80, she must make at least an 83 on the 5th test. All right, any questions about finding the mean, median, and mode for a data set? Okay. All right, so that's the measures of central tendency. Now let's look at how to choose the most appropriate measure of central tendency. Okay, now the mean is most commonly used as the average to describe a set of data. However, it might not always be an appropriate choice. And these are just some examples that I found. Let's say a company employs 20 people. The president of the company earns $200,000. The vice president earns $75,000, and 18 part-time employees earn $10,000 each. Is the mean the best number to choose to represent the average salary of the company? Now, if you took the sum of the salary of the president, the vice president, and 18 part-time employees, you'll get $455,000. Divide that by 20. The average there will be $22,750. The problem with that is that's not a representation of the mean salary of that company. The reason for that is you've got the president earning $200,000 and the vice president earning $75,000. They're making more money than the 18 part-time employees. So here, this is an example of a mean that can be affected by extreme values. Okay. Probably we could use either the median or the mode, because the median in this case is not going to be affected by the extreme values. So in this case, the middle number would be probably $10,000. That would be a better number to use to represent the average salary of that company. Also, the mode could be used as well because 18 part-time employees earn $10,000 each. That's the mode right there, the most frequent salary, but not the average. Now, here's another scenario. Let's say 9 students make up the following scores on a test. In this case, 30, 35, 40, 40, 92, 92, 93, 98, and 99. Now, would the median be the best average to represent the data, the set of scores? If you were to put this data set in numerical order from least to greatest, and then find the middle number, it would be 92. And besides, it's already in numerical order. So the middle number would be 92. Now, with a score of 92, if you were to use that median as the best average to represent the test scores, somebody might look at that and say, well, all the students did very well, but that's not the case. So probably if you were to take the average of all 9 scores, you would get like 69. That would be more appropriate. Okay. And here's another case here, where is the mode the appropriate average for these test scores: 40, 42, 50, 62, 63, 65, 98, and 98. Well, and we come up with a mode of 98. That's the most frequent score. It's also not a representative of this data set because you've got this huge spread of scores from 40 to 98. And the mean, which will be the average, which will be much lower. And with this data set, since it's in numerical order, the median would be like 62.5. That's a much lower median. So really, I cannot say what appropriate measure of central tendency to use for this situation. Just varies from one situation to another. Okay, any questions about measures of central tendency? Okay, I know I've got a lot of stuff I need to cover, but in this case, I need to stop right here. Oh, that's a lot here, so I'll stop with this.